See, name and signature of the method should be same. Unlike overloading. In overloading, name should be same, but signature should be different. Whereas in overriding, name and signature of the function should be same. Please remember this. Okay. Then the another building block of object-oriented programming, that is polymorphism. Polymorphism, which is implemented through this overriding only. So far we have discussed about the two different fundamental parameters or building blocks of object oriented, or features you can say, object oriented concept. One is abstraction and encapsulation, that is wrapping up of the data by using a different access control. Then second one is inheritance. So far we have considered about single and multi-level inheritance, right? How to pass the parameter and all to the superclass and superclass constructor as well, isn't it? Various topics we have discussed with respect to inheritance. Now continuation of the inheritance, that is polymorphism, single interface but multiple method. Single interface but multiple method implementation is done through this method overriding concept. Please try to understand. That's why it is one of the very important topic from this module. Okay, we are talking about the features or building blocks of object oriented concept. The next building block or feature of object oriented concept is the polymorphism only. That is what we are discussing just now. Now let us see one more example, the application of method overriding. Okay, another important programming example here. So what we are doing is, it's a practical example. We are finding the area of the rectangle, triangle, as well as the triangle is there, rectangle is there. Fine, we are finding the area of the triangle as well as the rectangle by method overriding, by implementing the method overriding concept. Let us see how. So this uses the runtime polymorphism. The meaning of runtime polymorphism I'll explain later. Let's consider the program. The class module, that is FIGURE, figure is the class module. Hope it is visible, which contains two variable, dimension 1 and dimension 2 of type double. Fine, it has got a constructor with two parameter, A and B. A is assigned to dimension 1 and B is assigned to dimension 2. Then there is a method, right? Area for the figure is, so here area is undefined. So what we are doing, we are just returning the value of 0. We are not computing anything, it is just a figure. It can be a triangle or it can be a rectangle. We are going to see that later. So we are overriding the method area. Let's see how to do this. Now class rectangle, which inherits the properties of figure, as you can see, which extends the property of figure, right? It has got a constructor with the two parameter. Whatever the constructor two parameters it receives, it will be passing to the base class constructor using a super keyword, as you can see over here. Then go through the command line, override the area for rectangle, isn't it? Here double area, we are as you can see, we are updating the value of area, that is system.out.println inside area for rectangle is printed. So it returns, instead of 0 returning 0, it returns, since parameters are passed now, that is dimension 1 into dimension 2, it returns. Okay, next class, which again extends the properties of figure only. Please remember, it is not a multi-level inheritance, because triangle, this does not inherits the properties from a rectangle. Instead it inherits the properties from figure only, right? As you can see. So class triangle, which extends the properties of figure, and what it does is, it prints it takes two parameter A and B, similar to the rectangle. It passes the parameter to the superclass. So A dimension 1, A will be assigned to dimension 1, B will be assigned to dimension 2, but area of triangle is different, as you are aware of, it is half into dimension 1 into dimension 2, or base into height, whatever, isn't it? So dimension 1, 2, the product value divided by 2, it returns, as you can see over here, right? Fine. Dimension 1 into dimension 2 divided by 2, check. Then the main function, object, which involves the object creation step. So from all the 3 class modules, we are going to create one object. Figure F object is created, rectangle R object is created, triangle T object is created. First figure F, new figure of 10 and 10. So whenever the object is created, its constructor will be called. So what it does, its constructor will be called 10 and 10. So A is taking 10, B is taking 10, A is assigned to dimension 1, B is assigned to dimension 2. That is for figure. Then rectangle R, which note down the things better. Rectangle R, what it does, so R, which is passing 2 parameter, right, 9 and 5. That 9 and 5 rectangle constructor, observe the rectangle constructor, 9 and 5 will be passed to the base class 9 and 5. Dimension 1 will be 9 with respect to rectangle, dimension 2 will be 5. That is done by the superclass. Then a T, once again taking 2 parameter, its constructor takes 2 parameter, that 10 and 8, you are passing 10 and 8, right? For triangle, A will be receiving 10, B will be receiving 8. So 10 into 8, that will be that assignment, dimension 1 and dimension 2 assignment will be done by the parent, that is figure. Fine. Here, to implement the runtime polymorphism, what we are doing is we are creating the reference. Please remember, object creation step involves the mentioning of the new keyword, but observe the difference between the first 3 statement and the 4th statement, which I have put the tick mark. Is there any new keyword you have used? There is no new keyword. Figure, so observe the first statement, figure F, which is equal to new of figure 10 comma 10. This is the first statement. Now observe the difference between the first as well as the 4th, which I am pointing or highlighting, right? Figure, now name of the object is FIGREF, fig reference, but which is equal to, we have not considered equal to new. It would be, if it is an object, it would be having the statements like equal to new of figure followed by so and so, right? Its constructor name and all, nothing is mentioned. That means it is just an reference. Please remember, since it's a reference, it can point to any of the object. It acts as a pointer. So this pointer is referring to the object R as per the first statement. Observe the thing which I'll put tick mark. So FIGREF, that is fig reference, which is equal to, this pointer holds the object. Which object it is holding? It is holding the value of R, isn't it? So R is assigned to fig reference. So fig reference dot some method which should be equal to R dot method. Observe the next statement, area, that is, sorry, system.out.println, area is, so fig reference dot area, FIGREF dot area, this is equal to, this is equivalent to what is fig reference? Fig reference is pointing to R. Now this is the same as R dot area. So you have to observe what is sorry, R dot area. So what is R? R is the rectangle object. Observe here, rectangle R, new rectangle of 9 comma 5. So fig reference dot area, which is equal to R dot area. Observe the rectangle module, R dot area, it returns dimension 1 into dimension 2. What are the parameters of dimension 1 and dimension 2? Here I have listed 9 and 5, isn't it? So 9 into 5, it will return. 9 into, try to understand, it will return 9 into 5, same thing will be printed. What is 9 into 5? 45. 9 into 5 is 45, same thing is printed. See, inside area of rectangle, that is what printed by the constructor. This constructor prints not constructor, sorry, uh, it has got a printf statement first inside area for rectangle, right? Inside area for rectangle or area of rectangle, whatever you have typed, it will be printed first, followed by its value, return value. So inside area of rectangle will be printed first, or area for rectangle, whatever, as you can see, followed by computed answer. What is computed? 9 into 5 is computed, 45 is printed. Then observe the runtime polymorphism in the sense you are changing the value of the reference during runtime, not compile time. It is not static. Its value is keep on updating. Now fig reference value is updated. What is the new value you have assigned to fig reference in this step? By this step, you have initialized a new value to the pointer what you have created or reference you have created. That is, you have initialized it with t, isn't it? Earlier in the previous instance during runtime, it was holding the value of r. Now it is holding t. So by this step, fig reference dot area, what does it indicate? It is equivalent to, observe the previous statement, you will come to know. Earlier it was r dot area, isn't it? Now it will be t dot area. That's it. What is the t? What is t signifies? T is the triangle class object, isn't it? So earlier it was r dot area. Now better observe this statement. Area is, okay, area is fig reference dot area. This fig reference, it indicates that it is, or it is equivalent to t dot area. T dot area. So what is t dot area? Triangle object. It is t is the triangle class object. So triangle class object, observe here, two parameters we have considered is 10 and 8. So triangle class object area of a method will be called. Inside area for triangle, this thing will be called, right? Return dimension 1 into dimension 2 divided by 2. That is 10 into 8, 80 divided by 2, 40 will be returned. First statement will be printed inside area of the area for the triangle. So this statement will be printed first, right? Area is inside area of the, sorry, triangle. Area is printed. What is the area value? Area is C. Area is followed by 40, 80 divided by 2. That is printed. Observe the main function. Next statement. In a runtime or during runtime, you are updating the value of the reference, fig reference. New value you are giving now. What is the new value? You are giving f. F is the figure class object. Observe carefully and call for the area, figure class object. See, it returns 0, right? Observe the figure class object. This statement area, what it returns? It returns, see, it returns 0. Area for figure is undefined. A message will be written, followed by a message will be printed, followed by value 0. It is not computing anything. So check the output. So fig reference dot area, which refers to this fig reference dot area, which refers to what? F dot area by this step, isn't it? So this refers to f dot area, right? So f dot area, it refers to area for figure is undefined. The message will be printed, followed by area is 0. Please try to understand. This is called as runtime polymorphism. Runtime polymorphism in the sense during runtime you are going to update the reference object, right? So you are going to update the value of the reference object, and each time you are going to call the same method but different method body. So single interface, that is what single interface multiple method refers to. The single interface is the fig reference, but that same interface fig ref, try to understand the same interface every time we have used fig ref, right? This implements different method during different interval. If you have any doubt, you ask. A very simple concept, straightforward concept, one of the very important topic from this module. Okay, every time, that is every regular interval, we are going to update the value of the fig reference. So what it does is, at every regular interval, this updates the value of the I mean that fig reference value will be updated at every regular interval. So the same interface we have used, but though we are executing the different methods at different intervals of time. That is why it is called as runtime polymorphism. Okay. If you have any doubt, feel free to ask. Let us continue our discussion later. Thank you for watching the video. If you have any doubt, you ask. Okay, repeatedly I am telling you, and please note down the program. The screenshot of the program, though we have discussed multiple programs today, but they are all interrelated. That continuity should be there. That's why I have considered. If you have any doubt, you can ask anytime. Okay, and please note down the programs and note down its working. Thank you for watching.